In this program, we will see the different types of interlocks. Okay, as you can see here, I have got input 1, input 2 and input 3. We'll play on these three inputs. All three are normally open contacts, NO contacts. Let me consider these as push button 1, push button 2, okay, and push button 3. And let me consider output 1 and output 2. So we'll see one type of interlock in which when I press this push button, this output will turn on, and now I cannot turn on this output unless and until I stop this. Similarly, when I press this push button, let me generate this output. Now I cannot turn on this output unless and until I stop this one. That means when this one is running, I cannot start this output, and when this one is running, I cannot start this one. So I want this type of interlock. So for that, let me take this as the start of this output and this input as the start of this output, and this is the common stop. So this interlock, I require this stop to press. So stop is mandatory in this type of interlock. So we'll see the ladder and then we'll download it and then we'll run it. So let me take the ladder. In the ladder I am taking X0 as, let us say, push button 1, and I will show an output Y0 as a motor 1. Let me latch the output Y0. So take the vertical line. Similarly, let me take another input, let us say X1 as push button 2, comment I have already given, and Y1 as a motor 2. Similarly, I am latching the output Y1 with the start of the second, that is X1. So let me put a vertical line here. I want to say stop. When I am pressing the stop, it must stop. So X2 is my stop, that is normally closed, because my input is normally open, hardware is open, so I have to take here NC. Now in this case, I said stop is mandatory. This stop I have to press. Only I can, means after then only I can change over from here to here. Okay, this stop is required. So what I have to do is that I must take this output here as a normally closed contact. See what I am doing, Y0, and this output address I must take here as a normally closed contact as Y1. That means this output, when it comes here as a NC, this will not allow to generate Y1 unless and until you say stop. And the same holds true for this Y1, this output and this contact. So let us download this program. So I am actually downloading it in the PLC, and later on in the same video we will see the simulation of this. Let me go online. Okay. So you see here, this is my X1. I press, X0. I press X0. I see that output is turning on. Now I cannot turn on this output unless and until I stop this. So let me use stop. Output is off. Now I can turn on this. So I press X1. This output is on. I can say stop. Now where is the interlock now? See now. When I press this input, this one is running. And if I try to run this by using the start, then it is not possible. See, it is not possible. On the ladder, if you check, the X1 is turning green, but output Y1 is not turning on, even if I give the start command, because this one is running. So I have to say stop. Only then, as a fresh output, I can start this one as a first. See, now it is turning on. Now I cannot turn on this Y0. Even if I press this push button, which is the start of this Y0, it is not possible. This is called as interlock. You check the ladder, which points are going off, which points are going on. Okay. When I say stop, this particular output will be off. So in this ladder, I have to say stop to change over. For this, I have taken output interlocks, output point to the input side as an interlock. So this Y0 is going here and this Y1 is going this side. So outputs are interlocked and stop is mandatory. Stop I have to press to change over. Suppose now I want a program like this in which when I give this input, this output should directly turn on, and when I give this input, this output should turn on putting off this. Again when I press this input, this output will go off and this output will be on. I want a direct reversal. I don't want to press stop. So in this program, stop will be not mandatory. Whatever input I give, instantly that respective output should turn on. Again, only one output should be on at a time. Like in this example, we have seen that I cannot turn on both the output. You see here, first output is on. Now I cannot turn the second output. I have to say stop. Again, when the second output is on, I cannot turn on the first output. That means I cannot turn on both the outputs at once, at one time, not possible. So that is called as interlock. So as I said, I want a direct reversal now. When I give this input, this output should turn on. When I give this should go off and this should run. For that, we have to just interlock the inputs. So I'll go offline. Interlocking the input, that means this X0 must come here instead of Y0. So I'll just double click, I'll remove this Y0 and let me take X0. And this X1 must come here. So this is called as interlocking the input points. X1. Now let me download. And both this program we'll see on the simulator. Now I am downloading in the actual PLC, so I can handle the input push buttons. Okay, so this is the input interlock. Let us check the panel now. I am giving X0. I see that Y0 is turning on. The moment I give X1, Y1 will turn on. No need to press stop, and this one will go off. See. Okay, I can directly jump from one to other. No need of stop. This is called as a direct reversal, a type of interlock wherein both outputs cannot be turned on. The moment I try to turn on this will go automatically. See, without pressing stop. But always remember, you just cannot remove stop from the ladder. X2 you just cannot remove, because in this program now either of 2 is going to remain on. Either this one will remain on or this one will remain on. So how to put it off? We just cannot put off the power of the system, right? So we require a stop for that. So the moment I press stop, the output which is kept on is off. Okay, so when I say start, I can say stop. To put off this, no need to put on this. Okay, so let me check again. Start, stop, again start, stop. But when I say start, I cannot turn on this. Sorry, I can turn on this by putting off this. No need of stop. Again, if I say start here, this one will go off, this one will turn on. No need of stop. But to make completely off, I require a stop. So I just cannot remove the stop from the ladder. So in this we have seen both input interlock, okay, where the stop is not mandatory, okay, and when we say output interlock, stop is mandatory.